Okay, this video is for Algebra 2. This is your 8.4 through 8.6 quiz review. Kind of tough stuff, so we're going to go over some of these problems together here. Okay, so number one, we're going to multiply these two rational expressions. Now notice you see a whole bunch of plus and minus signs. We need to put all of these in parentheses. Okay, so the first numerator says x squared minus 5x plus 6. We're looking for the factors of 6 that will combine to get negative 5. Well, that would be negative 2 and negative 3. So from this 6, negative 2 and negative 3. So this first numerator is going to factor into x minus 2, x minus 3. Okay, the denominator is a difference of perfect squares. X squared minus and 4 can be written as 2 squared. So this is x minus 2x plus 2. Remember, a difference of perfect squares, same terms, x and 2, but the different signs. Times. Okay, second numerator, x squared plus 2x plus 3x plus 2. Factors of 2 that make positive 3 are positive 1 and positive 2. X plus 1, x plus 2. And now the last denominator, x squared minus 2x minus 3. Factors of negative 3 that make negative 2, negative 3 and positive 1. X minus 3, x plus 1. And now, once you have all of them factored, now we draw that big bar across because it's multiplication, and we're just going to start canceling things. Okay, this x minus 2, cancel with that x minus 2. This x minus 3, cancel with that x minus 3. This x plus 1, cancels with that x plus 1. This x plus 2, cancels with that x plus 2. Uh-oh, everything is gone. When everything is gone, that is simply 1 over 1, which equals the number 1. Okay? Factor and look to cancel. 2. We're going to look at the division problem here. Now, immediately, we never divide. We always multiply by the reciprocal. So do not divide. Multiply by reciprocal. Okay, so we're going to multiply by the reciprocal of the second fraction. So we have 7x over 4y cubed times 8y over 21x cubed. Okay, and here's what I would do: is I would break some things down. Okay, so I see a 7 here. 7 cannot be broken down. And I see an x. Can't be broken down. Now, 4 can be broken down. 4 can go into 2 times 2. And and y cubed is 3 y's. So this is me kind of factoring. I'm breaking it down into its small parts, okay? Now, 8 here, 8 can be written as 2 times 4, and 4 can be written as 2 times 2. So 8 is 2 times 2 times 2. That'll make me 8 if I multiply them all together. And I have a y over, and now 21 can be broken into 3 times 7. And I see 3 x's, x, x, x. And now, I'll draw my big bar, and I will start to cancel things. 7, 7. This x, one of those x's. 2, 2, 2, 2. This 2 stays there. Y, y. Okay, so all the top is just the 2 now. And now the bottom, this y stays, this y stays, this 3 stays, this x stays, that x stays. So I have 3, 2 y's make y, we'll go in alphabetical order. 2 x's make x squared, and 2 y's make y squared. And there's how that simplifies down. Okay? So notice this one didn't have any plus or minus signs, so we just simply break them down into their parts and cancel common things. Alright. 3. Okay, we are going to subtract these two rational expressions. And in order to subtract, we need to obtain what is called the LCD, the least common denominator. And the least common denominator is obtained by factoring these denominators. So again, I see plus and minus signs. I'll put parentheses here and here. And now I need to factor. Okay, the factors of -2 that make a -1. Well, that would be -2 and +1. That would multiply to give me -2 and add to get me -1. So this first fraction is 2x over x minus 2x plus 1. Minus. And now the second denominator, factors of 2 that make -3 are going to be -2 and -1. They multiply to get +2, they add to get -3. So my second fraction is 4x over x minus 2, x minus 1. Okay, and now what we're going to do is we're going to look at our denominators and get a common denominator. So to get that, we look at the first denominator and write it down. X minus 2, x plus 1. And then I look and say, okay, the second denominator, is x minus 2 already there, or would it be new? And this x minus 2 is already there, so don't write it down. So we don't write this one down. X minus 1, is it already there, or do I need to write it down? Well, it's not already there, so I need to write it down. And this is my LCD. X minus 2, x plus 1, x minus 1. So now, what is each denominator missing? What is this denominator missing? Well, it's missing the x minus 1. Multiply by x minus 1. If I do it on bottom, I got to do it on top. What is the second denominator missing? It's missing the x plus 1. Multiply bottom and top. And now, the fact that I have the same denominator means I can make this into one big fraction. So here's what I'll do. I'll write that LCD down here. X minus 2, x plus 1, x minus 1. That's my denominator. And now both numerators are going to go on top of this with a minus sign in between them. So the first numerator is 2x times x minus 1 minus the second numerator is 4x times x plus 1. Okay, over here in blue, I'm going to bring it over here. Now we're going to simplify the top by distributing the 2x and making a 2x squared minus 2x and distributing the negative 4x. Minus 4x squared minus 4x. And that's all going to go over that LCD, which we do not touch, of x minus 2, x plus 1, x minus 1. And now we combine our like terms. I see a couple 2x, I see a couple x squareds. 2 minus 4 is negative 2x squared. I see a couple x's, negative 2 and negative 4 is negative 6x. That's all over your LCD. And that would be fine. That would be a final answer for me. Okay? Now, if I tell you to go one step further, you might have to factor the numerator a little bit. This numerator can be factored. Two terms, they have a common factor. The common factor here is actually going to be a negative 2, because 2 goes into 2 and 6. And both have at least one x, so the common factor would be negative 2x. So we would actually factor that out, leaving us with positive x and positive 3. So again, if I distribute it back out, negative 2x times x is negative 2x squared. Negative 2x times 3 is negative 6x. All over x minus 2, x plus 1, x minus 1. And of course, possibly, this would factor, the factored form would then cancel, but nothing cancels. So this would also be an okay answer. Okay, but again, the first one is what I'll accept in class. Just simplify that top once you get that common denominator, and you're good to go. Okay, so again, this is the toughest problem, right? This is a star. These subtraction problems are so tough. Okay, here we go. Number 4. We are going to simplify this complex fraction. So a complex fraction is a fraction within a fraction. So you see how you have a fraction in the numerator, this big fraction bar, and then you have two things, one fraction in the denominator. Okay, here's what I'm going to do. I'm going to rewrite. So let's rewrite this right next door. 3 over x minus 4 with parentheses, all over, and I'm going to give this 1 a denominator, so 1 over 1 minus 2 over x minus 4 in parentheses. And what I need, again, is I need an LCD. I'll put it in green here. Now, typically, they'll be factored for you already, so there's no factoring to do. So we look at each denominator and see if it's new or old. Start with the first one, x minus 4. Write it down. The second denominator is a 1. It doesn't really change anything, so I don't need to write it down. The third denominator is x minus 4. It's already there. This is your LCD, x minus 4. So in order to solve, or in order to simplify this complex fraction, we're going to take every numerator and multiply it by x minus 4. X minus 4, x minus 4, x minus 4. And here's what happens, okay? In the top, do you see how there's an x minus 4 in the bottom and the top now? They go away, and your top is just a 3. In the bottom, this 1 doesn't really matter on the bottom, so this is just 1 times x minus 4 minus, and now here, this x minus 4 and that x minus 4 cancel, 2. And now we just simply simplify. 3 over, distribute this 1, doesn't change anything, x minus 4 minus 2, and then combine your minus 4 minus 2. So this equals, so I'm going to go this way, 3 over x minus 6. And that's the final answer. So when you're simplifying a complex fraction, the big deal is get rid of the fractions within the fraction. Okay, 2 more here. Next, we're going to solve this equation, and we have to check the solution. So before I do anything, I'm going to rewrite this with a denominator of 1. So we have 5x minus 2, parentheses around it, over x minus 4, parentheses, equals negative 3 over 1. And I'm going to cross multiply this, right? So the 5x minus 2 gets multiplied by 1, so 1 times 5x minus 2 equals, and the negative 3 gets multiplied with the x minus 4, negative 3 times x minus 4. Now we distribute 5x minus 2, the 1 changes nothing, equals negative 3x plus 12. And now it's our job to solve this. Let's add 3x to both sides. Bring it up here. So I get 8x minus 2 equals 12. Let's add 2 to both sides. 8x equals 14, and we'll divide by 8. And you can give me a fraction or a decimal. If I do the decimal, I get 1.75, which is what I think you'll probably do. So this could possibly be my answer, 1.75, but I need to check. And the thing I must check is, let's make sure the denominator is not 0. So when I check, just make sure denominator does not equal 0. Right, that's all we're checking for. So my only denominator is x minus 4. Plug 1.75 in for x. This does not equal 0. So we're good to go. And that's our answer. Okay? Just be careful of those extraneous solutions, the ones that create a 0 in the denominator. Alright, so this is a proportion where you would cross multiply. Okay, last one here. This is a word problem. I'm going to add a formula here in the second. This formula will be given to you, so don't worry. So it says one pump can fill a tank with oil in 4 hours. A second pump can fill the same tank in 3 hours. If both pumps are used at the same time, how long will it take to fill the tank? Here's the equation I'll give you. So this is the equation, and it'll be given to you. 1 over T1 plus 1 over T2 equals 1 over x. Okay, and I'll say T1 is time for first pump. Maybe I should put P's. I'm sorry. So let's call this P1 and P2. So P1, time for pump 1. P2, time for pump 2. Okay. So what you will do is you'll fill in those numbers. Okay. So this is the formula. So we go 1 over, and P1, the time it takes is 4 hours, plus 1 over, and now P2, the time it takes is 3 hours, equals 1 over x. And our unknown is x. X is what we're looking for. Okay? So this is a rational equation. We have 3 denominators. We must find an LCD. This is different than the last problem. This is not a proportion. It's not a proportion. Because it's not one fraction and one fraction. One fraction equals one fraction. It's 2 fractions equals 1 fraction. So 2 fractions equals 1 fraction. Okay, so it's not a proportion. So we must find an LCD. Okay, so to do that, I'm going to break down the numbers if I can. So this 4, I'm going to actually break it down into a 2 times 2. Okay, and now when I look for my LCD, I'll do it in blue here. My LCD, I write down the first denominator, 2 times 2. 3 cannot be broken down, and it's new, so I write it down, 3. And x cannot be, changed, so that's an x. So here is my LCD, 2 times 2 times 3 times 3. Every numerator gets multiplied by this LCD, times 2 times 2 times 3 times x, times 2 times 2 times 3 times x, times 2 times 2 times 3 times x, right? Okay. And now, anything that's the same on top and bottom can cancel. So I'll do this in green. 2's gone with the 2. 2's gone with the 2. So my denominator is now gone, and this is 1 times 3 times x plus. In the second fraction, 3 cancels the 3. My denominator is now gone. 1 times 2 times 2 times x equals. In the last fraction, the x is gone, and now my denominator is gone. 1 times 2 times 2 times 3. Simplify this. This is 3x plus 4x equals 4 times 3 is 12. This is 7x equals 12, and let's divide by 7. And we'll round this to 1 decimal. So 12 divided by 7. 1.7, and that would be hours. Okay? And again, all you have to do is check to make sure that the denominator is not 0. Check for denominator not equal to 0. So the first 2 denominators are numbers, so as long as x does not equal 0, we're good. So that denominator is just 1.7, which does not equal 0. So we're good. So this is the time it would take for both pumps working at the same time. So I mean, notice it's smaller, and it should be, right? If 2 pumps take 3 and 4 hours, then together it should be smaller, and it's 1.7. Okay, so glad you watched. Bring it in for your bonus points, and we'll see you on Friday.